Alright, welcome back guys. We'll finish up here. Yeah, so interval notation. Remember with interval notation you'll have a starting and a stopping value. Okay, and remember we sort of treat like infinity as a number, but technically it's not. But anyway, it says, for example, consider all the real numbers between 1 and 10. Well, all the real numbers between 1 and 10 can be expressed in interval notation like this. Okay, we're starting at, well, where'd my cursor go? For some reason. Here it is. Okay, now it is. We're starting at 1, we're stopping at 10. Now we're using the parentheses because 1 and 10 are not included, because it just says the real numbers between 1 and 10. What about the second case here? All real numbers less than -5, but including -5. Well, all the numbers less than -5, then you'd be going from -infinity up to -5, and since we're including -5, we use a bracket. Okay. So those are just a couple examples. I know we've talked about this before, so I'm not going to spend too much time on it, but here's some other examples of 4 different intervals expressed 3 different ways. Visually, graphed on a number line, using set builder notation, and then also using interval notation. Okay, so you can look at these. Because for this last one, we're going to have to express the domain in interval notation. Alright, so let's look at this one. So we're given these 2 functions. They are not polynomials. They're rational functions. They have x's in the denominators. So we want to find the domain of f composed of g of x and g composed of f of x. Well, I tell you how to do that up here, this second bullet. So composing 2 non-polynomial functions. So you're going to find the domain of the function being inserted, in other words, the inner function. And whatever that domain is going to be part of the overall domain. Then you're going to actually compose the 2 functions, simplify, and see if there are any new restrictions on the domain. Okay. Alright, so let's try this. So you're going to first find the domain of the inner function, then you're going to do the composition and see if there are any further restrictions. Okay, so let's start with f composed of g of x. Okay, so if we want to find the domain for f composed of g, I'm not going to put the of x part, okay? This is shorthand. It's understood that this composition is a function of x. So sometimes people will not explicitly state x. Alright, well, what is the inner function here? The inner function is g, okay? So what we need to do first is we need to find the domain of g. Okay, well, let's see what g is. G is the function 1 over x. Okay, so if you remember, there is going to be a restriction. And the restriction just comes from what makes this denominator 0, right? Because we can't divide by 0. So whenever x is 0, this function g is undefined. Okay, so in other words, x cannot be equal to 0. Okay, so there's one restriction. Now what we need to do is actually find the composition and see if there's any more restrictions. Okay, so we are going to find f composed of g. So this is going to be equal to f of g of x. So in other words, we're plugging g into f. Okay, so f of 1 over x. So we've got to take this 1 over x and plug that into the x in f right here. All right, so f is 7 over, and then in the denominator we have 1 minus 8 times, now we're going to plug in g, which is 1 over x. Alright. If I were to simplify this a bit, I can multiply 8 times 1 over x, and that'll give me 7 over 1 over, 7 over 1 minus 8 over x. And you may think this is simplified, but we don't typically like to have a fraction within a fraction. And so what we want to do is somehow eliminate this fraction that's here in the denominator. And you can do this, guys, by multiplying both the numerator and denominator of the larger fraction by whatever this denominator of the smaller fraction is. So since it's x, if I multiply, well, I'll show you. The numerator by x and also the denominator by x. Okay, then the numerator will turn into 7x, and then here you're going to have to distribute. So x times 1 is going to be x, but when you multiply x times 8 over x, the x's will divide out, or cancel in other words. And so you're just going to be left with minus 8. That's the whole purpose here, so that you divide out or cancel out that denominator. Okay. And so what we're left with here is just one fraction. Okay, so we don't have a fraction within a fraction. All right, so this is the actual composition. F composed of g of x is this rational function right here. Now we've got to look and see, are there going to be any more domain restrictions on this guy? Well, is there a value for x that'll make this denominator 0? Well, there is, and that value is 8. Okay. In other words, we don't want the denominator to equal 0. And the only value that will make it equal 0 is when x is 8. Okay, so that is another restriction. So x cannot equal 8. So anyway, the only restriction that we have on our inner function here is 0. But then we garner another restriction when we actually do the composition. Okay, so the actual function itself that results has a restriction of 8. So we end up with 2 restrictions. So for the domain here, actually, let me just kind of carry this down. We don't want x to be equal to either 0 or 8. Alright, so now let me express this in interval notation. That means we're going to be going from negative infinity up to 0. We're not including the 0. And then we're going to go from 0 to 8, not including the 8. And then we're going to go from 8 to infinity, but again, not including the 8. Okay, so basically what we've done, the domain is all real numbers except for 0 and 8. So we're just taking out 0 and 8. Alright, well, I'm going to draw a line to kind of partition this from the second part. So for the second part, we want to do the reverse. We want to find the domain of G composed of F. Okay. Alright, so in this case, F is your inner function. So I need to find the domain of F. Okay. There we go. So the domain of F. Well, F is this guy right here. 7 over 1 minus 8x. And so, again, it comes down to that denominator, right? What's going to make that denominator 0? Well, this one, it's not so straightforward. So you may want to set it equal to 0 and solve it for x, and that'll tell you. So if we solve this for x, we're first going to have to subtract this 1 from both sides. And that'll leave us with negative 8x is equal to negative 1. And then we would divide both sides by negative 8. And that'll give us x is equal to, that'll become positive 1/8. Okay? So that is the restriction for the inner function. X cannot be equal to 1/8. Alright, so now, just like the last one, we need to actually find the composition. So we're going to, again, find G composed of F. Okay? So this will be G of F. In other words, we're just plugging F into G. So G of F in this case, well, we just saw it, it's 7 over 1 minus 8x. Okay, so that's what we plug into G. I'm going to zoom out a little bit so you can still see, reference those two functions. So 7 over 1 minus 8x, that's going into G. Well, where's the x in G? It's down here. It's in the denominator. So this will become 1 over 7 over 1 minus 8x. Okay? Alright, well, we see the same thing occurring that we saw in the last one. We've got a fraction within a fraction. Okay? I'm going to rewrite this over here. So we treat it the same way. We multiply the numerator and the denominator by whatever this denominator is. In this case, it's 1 minus 8x. Okay. And, well, let's take care of the denominator first, because this 1 minus 8x will cancel this one, and it'll leave us with just 7 in the denominator. Okay, so we'll just have 7 down there over, but then up here, 1 minus 8x times 1, well, technically you could look at this like you're distributing 1, but 1 times anything is itself. So this will just become 1 minus 8x. And so this is the composition. Okay. This is G of f of x right here. Well, let's see, is it going to have any restrictions on its domain? Well, look at its domain. Its domain doesn't have an x in it. Okay, so there aren't going to be any more restrictions. This domain here will never be 0. It can't. It'll always be a 7. So this function will always be defined for any value of x. Okay, so the only restriction that we found here in doing this was the restriction on the inner function, 1/8. Okay, so to find the domain then, x cannot be equal to 1/8. So to write this in interval notation, we're going to go from negative infinity up to an 8th, and then we're going to go from an 8th all the way to positive infinity. Again, in other words, we're just taking an 8th out of the domain. So that composition, or this new function here, it'll take anything except 1/8. Alright guys, well, I tried to give you an example similar to what you'll see in your homework. One each, basically, for the most part. Alright, and so I'll see you in the video for 9.2.